Let's take a look at the practice questions on perimeter and area of a rectangle. The first question says, what is the perimeter of an isosceles right triangle with side lengths of 5? So we have some important information here given in our question. First, we have an isosceles right triangle. So that's telling us we have a right triangle and is isosceles, which means that the two legs are the same length. Okay, and we're looking for the perimeter. And remember, when we're talking about perimeter, we're going around the outside edges. And the perimeter of a triangle is just going to be the sum of the three sides. So sum of side 1 plus side 2 plus side 3. We know that side 1 and side 2 are the same thing. We could call that x. Really, it's 2x because we have side 1 plus side 2. We have x and x. And then plus that side 3 here. So we'll call this x, and maybe we'll call this one side 3. Okay, so we know that the side lengths are 5. So we can label that. So one thing that this already tells us, since we know we're adding up the three sides, 5 plus 5, that's already 10 with just 2 of the side lengths, and we know we have a value for S3. It's got to be greater than 10, so answer choice A is out. Now, how do we find this third side length? Well, given that it is a right triangle and we have 2 side lengths, we can use the Pythagorean theorem, which is a squared plus b squared equals c squared. And how does that correspond to what we're using? We're using a and b, the side lengths of x and x, which are really equal to 5. So we've got 5 squared plus 5 squared equals our hypotenuse squared, hypotenuse being the side lengths opposite of the 90-degree angle, that's the hypotenuse, c squared, which we had labeled S3, but I'm going to label it as c, equals c squared. We want to solve for c so that we can then plug in and add those 3 up and find our perimeter. So we have 25 plus 25, which is equal to 50. That is equal to c squared, but we need to know what c is, so we're going to take the square root. And so the square root of 50, we can simplify that into 5 on the square root of 2 because it's 25 times 2 under the radical, bring the 5 out. So we have c is equal to 5 on the square root of 2, but this is not our final answer. Remember, again, ultimately we were trying to find perimeter, which turned out we can plug each of these values in, 5 plus 5 plus 5 on the square root of 2. And that will give us 10 plus 5 on the square root of 2. We cannot simplify this anymore because we have a radical right here, no radical over here. So that's as far as we can go if we are to give exact values, which is with the radical. And that's going to be answer choice C. Now let's take a look at number 2. If a rectangle with an area of 42 square units has a length of 7 units, what is the rectangle's perimeter? Okay, so we're given area, we're given one of the lengths, and we're asked to find the perimeter. So let's remind ourselves of a rectangle. Area is equal to the length times the width, and for the perimeter of a rectangle, it is equal to 2L plus 2W. Remember, we're just adding up the 2 lengths and the 2 widths. Area, we multiply the length times width. Well, we're given that the area is 42, and we're also given that the length is 7. We don't know what W is. We need W over here. We have L, so let's find W. We can solve for W by dividing through by 7, and 42 divided by 7 is 6, so that gives us our width. So now we can plug that into our perimeter formula. 2 times 7 plus 2 times 6, and that turns out to be 14 plus 12, which is 26. That is answer choice J. Okay, now let's take a look at number 3. In the figure below, all of the small squares are equal in area, and the area of the rectangle is 1 square unit. Which of the following expressions represents the area in square units of the shaded region? This is a problem that we have come to see quite often on the ACT, so it's a good idea to get familiar with how to calculate this. We can look at the shaded region as parts or pieces or fractions. And the reason I say fractions is I'm looking over here at my answer choices and I see that they are in fractions. Let's remind ourselves of the area of a rectangle is just length times width. So if we know the length and the width and of the shaded region, we can figure that out. Well, let's look at this. If we look here at the width, if we want to use the width here, we have 1, 2, 3, 4 units shaded of the 5. So 4 out of 5 are shaded times, let's look at how many on the other dimension, 1, 2, 3, 4, 4 out of a total of 6. So that gives us 4/5 times 4/6 is the area of the shaded region. And that corresponds to answer choice E, 4/5 times 4/6. All right, now let's look at the back side of these questions. Question 4, a rectangle is 2 on the square root of 7 feet wide and 3 on the square root of 7 feet long. What is the area in square feet of the rectangle? And we've talked about area before of a rectangle. We'll write it down. Area is just length times width. They give us both the length and the width here, width and the length, and so we can just plug that in. But we've got to multiply, it looks like, with radicals, and so we can handle that. Let's just remind ourselves, when we're going to multiply with radicals, we're going to multiply the outside. 2 times 3 is 6. And we multiply what's under the radical. Square root of, we have the square root of 7 times the square root of 7, so you're just multiplying 7 times 7, which is 49, and you know that turns out to be just pulling a 7 out. So we'll have 6 times 7 is 42. So that is answer choice G. You should also know how to put radicals in your calculator, so you could do that as well if you didn't do it by hand, and you would have still come up with answer choice G, 42. Question number 5. The Tanners are installing a 15 feet by 30 feet rectangular pool in their 75 by 50 feet backyard. They are also enclosing the yard and pool with a fence and the back of their house. See the figure below. What is the minimum number of feet of fencing needed to enclose the yard? So when I hear fencing, when I think about fencing, I want to think about perimeter. We're going to go around this yard, and we're using the back of the house as one of the borders. We're not going to put a fence here. There will not be a fence there. So the fence will begin here, or on this side it goes around from those sides. So we still have some pieces that we need to look at calculating. So what's the minimum number of feet? Okay, we know, so we're looking for perimeter. We know we have 75 feet across here. We have 2 lengths right here of 50, so we could do 2 times 50. And then how do we determine this area here and here? Well, we know the total was 75, and we could subtract out the length of the house, which is 40, and that gives us how much on either side there. And then we can just add up those numbers, 75 plus 100 plus 35. So when we add up those 3 numbers, we get 210, which is answer choice C. Let's take a look at question number 6. If 3 feet of concrete is added all around the edge of the pool, it creates a larger rectangle. What is the area of the grass remaining inside the fenced area? So we're looking for an area here. So when we look at this pool area, we'll do another drawing here. So that's the whole backyard, and we've got the pool here. We're also going to add this concrete around the pool, 3 feet around it. And so we want to know what the area of this is. So it would make sense to take the area of the entire yard and subtract out that pool and concrete area. So first let's figure out the area of the entire yard. And that we're going to do is length times width. And we were given those values of 75 and 50. So that gives us an overall yard area of 3750. Now let's think about the pool. The original pool dimensions were 15 by 30, feet, and we're going to add 3 feet of concrete all around. So you're going to add 3 feet on this side for the length, and 3 feet on this side will give us a total of 6 feet. So instead of the dimension being 30, it's going to be 30 plus 6, 36. And for the width, the 15, again, 3 on this side and 3 on this side, we're adding 6 to the length. Gives us 21. So now these are our 2 new dimensions that we'll use for the pool. So the area of the pool is going to equal to 36 times 21. We get 756. This is the area of the pool and the concrete that's going to go around it. So we're really going to take now this 3750, which remember was the total area of the backyard, subtract out the pool and concrete area, and we get 2,994. That is answer choice H. Question number 7. The area of the pool and concrete, so the pool and the concrete, is what percent of the area of the yard? So remember, we found the area of the yard and the area of the pool up above, but they're asking for a percent. So we're wanting to find the part over the whole. So the whole would be the area of the yard, which was 3750. And the area of the pool and concrete was 756. So this is just going to be a percent, a fraction. We look at our answer choices and they are in percent form. So when we plug this into our calculator, we do get a decimal, 0.2016, but we want that in percent form. So we move the decimal 2 places to the right and we get 20.16%, which is answer choice B.